In this video, we'll talk about case control studies, another study design that allows us to examine the association between exposures and disease outcomes. Let's briefly review cohort studies so that we can contrast them with case control studies. The key feature that defines a cohort study is that participants are sampled based on their exposure, and so the groups we compare are groups defined by exposure status. What's nice about cohort studies is that we're able to estimate risk, and also we can establish that exposure happened before the disease outcome, which is essential for causal inferences. The main drawback is that for rare disease, we likely need to follow subjects for a very long time or enroll a huge number of them to see enough cases of disease. This is where case control studies would be preferred. In case control studies, participants are sampled based on their disease status rather than on their exposure status. So the groups we end up comparing are the groups formed by disease status rather than those formed by exposure status. So in other words, we first identify individuals who have disease, called cases, and individuals who don't have disease, called controls. And we obtain information about their past exposures by conducting interviews, consulting hospital records, or similar. The rationale for this study design is that if exposure is positively associated with disease occurrence, most of the cases should have been exposed, and most of the controls should have been unexposed. For both cohort and case control studies, we can organize the data collected into a 2x2 table of counts. In cohort studies, we computed the risk of disease in the exposed and unexposed groups, and we compared them using a ratio called the risk ratio or relative risk. We did this to measure the strength of association between exposure and disease. Can we calculate risk of disease in case control studies? In general, no, for a number of reasons. First, to calculate risk, we need the population at risk for the disease in the denominator. Because we are in control of the number of cases and controls that we sample, the size of the exposed population relative to the unexposed population is likely far off from what we would obtain in a cohort study. Second, and related to that first reason, if we just sampled a lot more controls, counts B and D would grow, changing both the individual risks in the exposed and unexposed groups and the risk ratio. A good measure of association should not be affected by this. Finally, it can often happen that the cases sampled in case control studies are prevalent ones rather than incident ones. And as we know, it's incidence rather than prevalence that measures the risk of getting disease. So ideally, we would like to conduct a cohort study to estimate a relative risk. Is there a way for us to approximate the relative risk from a cohort study when we have data from a case control study? We'll see that another measure of association, called an odds ratio, provides a good estimate of the relative risk and can be computed in either cohort or case control studies. So to build up to odds ratios, we first need to discuss odds. So suppose that P is the probability or chance of some event. For example, the probability of rolling a 1 through 5 on a 6-sided die is 5/6. The odds of an event are defined as P divided by 1 minus P. So the odds of rolling a 1 through 5 is 5 divided by 6 over 1 divided by 6, or 5. Odds ratios are the ratio of two odds, and odds of an event in one condition divided by the odds of the same event in another condition. For example, we could compute the odds of exposure in those with disease and the odds of exposure in those who don't have disease. This gives us a way to measure the association between exposure and disease, and it's actually the measure that we'll use for case control studies. So let's look at both the relative risk and odds ratio for both cohort and case control studies. The relative risk is the chance of disease in the exposed group over the chance of disease in the unexposed group. An important note, if the disease is rare, meaning that the A and C counts are small relative to the B and D counts, then the relative risk is close to A over B divided by C over D. Let's compute the corresponding odds ratio for a cohort study. Instead of the ratio of the chances of disease in the two groups, we'll compute a ratio of the odds of the disease in the two groups. The odds of disease in the exposed is the chance of disease in the exposed group divided by 1 minus that chance. This is the same as the chance of disease in the exposed group divided by the chance of no disease in the exposed group. This gives the numerator odds. The denominator odds can be calculated similarly. And after some algebra, this turns out to be A times D divided by B times C. We can similarly compute an odds ratio in a case control study. The difference is that in a case control study, we start with cases and controls rather than exposed and unexposed. So the groups we compare are the cases and the controls. This means that instead of computing the odds of disease in the exposed, we compute the odds of exposure in the diseased, the cases. Remember that this is because we generally cannot estimate risk in a case control study. The odds ratio in a case control study actually ends up being the same as the odds ratio from a cohort study. So let's put together the implications of these results. The odds ratio from a case control study is the same as the odds ratio from a cohort study. And the odds ratio from a cohort study is a good approximation for the relative risk from that cohort study if the disease is rare. This means that the odds ratio from a case control study is a good approximation for the relative risk from a cohort study when the disease is rare. Rare diseases are often the ones for which we like to do case control studies. If the disease is common, the approximation would be worse, but in this case, it would be more feasible to conduct a cohort study. So in summary, we've introduced case control studies as an alternative to cohort studies when the disease of interest is rare. In these situations, it would be resource intensive to conduct a cohort study. In case control studies, we generally cannot estimate risks and risk ratios as we do in cohort studies because we start with cases and controls rather than starting with exposed and unexposed. For this reason, we use the odds ratio, specifically the odds of exposure in cases versus odds of exposure in controls. We use the odds ratio to measure the association between exposure and disease. We saw that this ends up being a good approximation for the relative risk from a cohort study when the disease is rare. Note that even if the disease is not rare, the odds ratio is still a measure of association between the exposure and disease, even if it doesn't approximate the relative risk well. Also, it happens to be the case that the odds ratio is always further away from 1, which is the neutral or null value for ratios. It's always further away from 1 than the relative risk. It's important to keep this in mind when interpreting the numerical value of the odds ratio.